Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over how to apply the chain rule in finding the derivative. There are going to be 4 practice problems at the end of this presentation that we'll like you to try out in order to demonstrate mastery of what we covered in this tutorial. Alright, before we get started, we're going to take a look at the formula that's going to guide our problem solving process. So you need to remember that the chain rule is a procedure for differentiating composite functions. Okay, so here's the formula for the chain rule. If you're looking for the derivative of a composite function, let's say f of g of x, so f of g of x prime, you differentiate this by finding the derivative evaluated at the inner, derivative of the outer function, which is f, evaluated at the inner function, times the derivative of the inner function. Okay, so just remember when you're using the chain rule, you differentiate one function at a time. Don't do them simultaneously and compose them. Okay, so let's go ahead and write down the procedure here. So you're going to carry out the derivative of the outer function. In this case is f. Derivative of the outer. Now when you're differentiating the outer, don't touch the inner. Okay, so derivative of the outer evaluated at the inner. So when you differentiate the outer, the inner is just going to serve as something you're going to substitute in. Okay, evaluated at the inner. And then you multiply times the derivative of the inner. Derivative of the inner. Alright, one common mistake that most students make is they do this. They say, okay, since we're differentiating f of g of x, I'm just going to differentiate and compose them simultaneously. So it's going to be f prime composed with g prime of x. This is not the chain rule. Okay, so you want to avoid making this mistake. You do one at a time. Alright, so the acronym for this is DOEIDO, derivative of the outer evaluated at the inner, times the derivative of the inner. So when we reference DOEIDO, just know that we're talking about the chain rule. Okay, let's go ahead and try out some problems. The instructions for the example that we're working on are as follows. We're to differentiate the following. Differentiate the following with respect to x. Okay, number one, let's say we have the function y equals quantity 3x to the third plus 5 raised to the fifth. Okay, so in this particular problem, we have a composition of a quintic monomial and a cubic binomial. All right, so we're going to apply the chain rule here. So y of, I'm going to color code it so you can easily identify the outer and the inner function. Okay, I'm going to make my inner function green and my outer function is going to be black. Okay, so let's go ahead. In order to help us apply the chain rule, we're going to decompose them so we don't get confused. The outer function is f of x. Okay, so let's call the outer function f of x, which is x to the fifth. And the inner function, we're going to call that g. A lot of textbooks call it u. It doesn't really matter, so we're just going to call it g. Okay, so we decompose first. And then what we're going to do next is we're going to differentiate both of them. Okay, so let's differentiate the outer function. Applying the power rule, f prime of x is power down x to the power minus 1, which is 4. And then the derivative of the inner function, oh snap, let me change my colors. So g prime of x is the derivative of the inner. So g prime of x is going to be, differentiate 3x to the third, you just power down Yeah, but there was a 3 there before, so it's going to be 9x power minus 1 square, and the derivative of 5 is 0. Okay? All right, so if we want to use the chain rule, derivative of the outer, which is 5x to the 4, evaluated at the inner. So what we're going to do is take g of x, the inner function, and plug it into the outer function. All right, times the derivative of the inner, which is 9x squared. Okay. All right, so our derivative in unsimplified form, dy dx, you can call it dy dx or y prime, it's the same thing. Okay, dy dx is going to be 5 times, so instead of x, we're going to replace x with g, which is 3x to the third plus 5 raised to the fourth power, times the derivative of g, which is 9x squared. Okay, all right, let's simplify that. So 9x squared times 5, that's 45x squared, times 3x to the third plus 5 to the fourth. And there goes the answer to question number 1. Let's call this dy dx. All right, let's take a look at another example. Now, what if we're dealing with a situation like this, number 2? What if we have y is equal to quantity 5x squared plus 1 to the third? We're going to be following exactly the same procedure that we implemented in number 1 here. Okay, so if you just take a look at number 1, if you're stuck, you're going to see exactly how it works. So we're going to have y equals, we're going to color code number 2 again to identify the inner and outer functions. So let's call the outer function, let's call it f of x. So the cubic monomial x to the third is the outer function. Okay, and then the inner function is our quadratic binomial that we have here. So let's call that g. So g of x is 5x squared plus 1. All right, so like we did in number 1, we're going to differentiate both, okay? So differentiate them separately. Derivative of the outer function using the power rule is 3x squared, power down, mark down. And then the derivative of the inner function, if you differentiate them term by term, the first one is 10x, and then the derivative of the second one, the constant, is just 1. Alrighty? Alright, let's do this real quick. So derivative of the outer evaluated at the inner. So you take the inner function and plug it into the outer, and then multiply that by the derivative of the inner. Okay? Alright, so y prime, which is the same thing as dy dx, is 3 times the quantity 5x squared plus 1. Quantity square. Alrighty. This is the derivative of the outer evaluated at the inner times the derivative of the inner, 10x. Alright, so your final answer, y prime, is going to be 30x times the quantity 5x squared plus 1, quantity square, and that's the answer to question number 2. Alright, let's take a look at 3. What if we have a rational exponent? Let's say we have y equals 3 minus 4x to the 5th raised to the 1/3 power. All right, let's go ahead and do this. We're going to follow exactly the same procedure as we did in problems 1 and 2. Okay, so let's write it down. Y is equal to 3 minus 4x to the 5th raised to the 1/3. Oh, let's color code this so we can see what the inner and outer functions are. So the inner function is the quintic binomial 3 minus 4x to the 5th. Okay, so we close that, raised to 1/3. Now, we're going to go ahead and decompose the function. to identify what f and g are, and then we're going to use the chain rule to find the derivative. Okay? All right, so our outer function is this radical function, y equals the cube root of x, so we just write it as x to the 1/3, okay? And then the inner function, g, is our quintic binomial, 3 minus 4x to the 5th. Okay, now let's differentiate. What did I call that y? Let's call the outer function f, okay? So call the outer function f. All right, so let's differentiate both of them. So the derivative of the outer function, power down 1/3 x to the 1/3 minus 1 is negative 2/3. And then the derivative of the inner function, let's use the power rule. The derivative of 3 is 0, derivative of, so don't forget that minus, okay? So it's going to be negative 20x to the 4th power. That's a common mistake a lot of students make when differentiating functions where there's a minus. They forget that negative, so don't watch out for that. All right, let's DOEIDO this. So derivative of outer evaluated at the inner, so we're going to plug g into the derivative of f. So, and then we're going to multiply that by the derivative of the inner right there. So what do we have? Y prime or dy dx is the derivative of the outer function evaluated at the inner. So basically take x out and replace it with the inner function. Alrighty. And then we multiply that by the derivative of the inner, which is negative 20x to the 4th. All right, and then if we want to, let's go ahead and simplify this. Want to make it look pretty. Our final answer, y prime, is going to be negative 20x to the 4th, and then divided by, we're going to use the reciprocal property of exponent to reciprocate this term right here with the negative exponent. So that's going to be on the bottom. In the denominator, there's already a 3 there, so it's going to be 3 times the quantity, 3 minus 4x to the 5th, raised to the negative 2 over 3. And that is the answer to question number 3. Okay, let's take a look at number 4. One more problem, and then you're going to have a chance to do some practice problems, as we promised in the start of this presentation. So now let's say you're looking for the 5th root of 2x to the 4th plus 1, okay? All right, so we're going to be using the chain rule here, following the same procedure that we did in problems 1 to 3. So y equals the 5th root of the inner function is a quartic binomial, 2x to the 4th plus 1. Okay. All right, let's decompose this. So our outer function f is the 5th root of x, this radical function right here. And our inner function g is our quartic binomial, 2x to the 4th plus 1. Okay, so now differentiating this, the form that this function f of x is in radical form is difficult to apply the power rule. So we're going to rewrite f. Okay, so let's rewrite f. We're going to rewrite f as a rational exponent. So f of x equals x to the 1 over 5. The index becomes the denominator and the power becomes the numerator in rational exponent form. We're just going to bring down g of x. Okay, we're not doing anything yet. We want to differentiate them simultaneously so that when we are applying the chain rule, we do not cause any confusion. So just bring this down. We haven't done anything yet. We just rewrote the first function f, so it's easy to differentiate. All right, so let's put a side note here. Rewrite f. Rewrite f as a power. So that's a differentiation strategy you want to keep in mind whenever you're experiencing complications. Finding the derivative, just see if you can rewrite it in a form that's consistent with one of the formulas that you already know. Okay, let's go ahead and differentiate. So derivative of the outer function, applying the power rule here, we'll have 1 over 5x to the power minus 1, which is negative 4/5. Okay, and then the derivative of the inner function is, so you power down 8x to the third power, and the derivative of 1 is just 0. All right, let's go ahead and DOEIDO this real quick. Apply the chain rule. Derivative of the outer evaluated at the inner, so you take the inner function, plug it in here, and multiply it by the derivative of the outer function. Okay, so our derivative, y prime, or dy dx, mean the same thing. In unsimplified form is 1 over 5 times the quantity 2x to the 4th plus 1 raised to the negative 4/5 times 8x to the 3rd. Okay, let's make it look pretty. What we're going to do here is just rewrite it in pretty print. So we're going to have 8x to the 3rd in the numerator divided by, in the denominator, we already have a 5 there, so it's 5 times. Now, since this quantity here has a negative exponent, it will be reciprocated. Okay, 2x to the 4th plus 1 raised to the 4/5. Ladies and gentlemen, that's the answer to question number 4. It's now your turn to do some practice problems. Alrighty, so we have 4 practice problems we would like you to try out. Instructions are for you to differentiate the following with respect to x. So what we'd like you to do at this time is go ahead and pause this video presentation, work on the 4 problems, and then when you're done, click back on the play button, and then we will reveal what the answers are. Welcome back. Hopefully you had a chance to try these problems. Let's go ahead and show you what the answers are. For number 1, the derivative y prime, or dy dx, however you want to write it, is 60x squared times the quantity 5x to the 3rd minus 4 raised to the 3rd power. Number 2, the answer, y dx, or y prime, is equal to 16x times the quantity 4x squared plus 5. Number 3, the derivative f prime of x, write that again, f prime of x is 4x over 3 times the quantity 2x squared minus 1 raised to the 2/3 power. Number 4, y prime, or dy dx, is equal to 60x to the 4th over the quantity negative 3x to the 5th plus 2 raised to the 5th power. All right. So how well did you do in these 4 practice problems? Let us know in the comment section below how well you did. If there are any questions, clarifications that you have, just specify it in the comment section below and we'll be glad to assist. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial helpful in your studies of differentiation, do give us a like or a thumbs up. Your positive feedback is very valuable to us. Do not forget to subscribe to our channel for updates to our uploads. We upload videos to our page on a regular basis. If you have any questions, comments, or special requests, just post it in the comment section below and we'll be more than glad to assist. Tons of resources can be found at our website, mathgotserved.com, or you can just take a look in the link in the description. Thanks again for watching and have a wonderful day. Goodbye.